Would a gold atom look golden? Would a single atom of gold conduct electricity? These are common questions in a science classroom, and the answer to both is a categoric no. To find out why the answer is no, and to prepare for GCSE exam questions on this topic, join me for a closer look at the particle model. In a previous episode, we introduced the particle model and saw how it applied to the three states of matter: solids, liquids, and gases. We looked at how the particle model could explain the behaviour of liquids and the transition into both the solid and gas states. If you haven't watched that episode already, then it might be a good idea to watch that first, as we're now going to look at the specific knowledge you will require to answer GCSE exam questions on this topic. These are the key areas that are asked within the AQA GCSE chemistry specification, but there is pretty much the same content on all chemistry qualifications at this level, as this is such core and critical information. The first two of these sections are relatively straightforward and are pretty much standalone when it comes to the course. We will look at them here in this episode. The second two are the start of a much longer journey into chemical structure and bonding, and so we will introduce the key ideas in the next video, and then we'll come back to them in detail across several future episodes. Let's start by looking at that first point about the bulk properties of a substance. The textbooks will tell you that gold is a yellow, orange metal, which is highly conductive and malleable, with a melting point of 1064 degrees centigrade. But how many of those facts relate to a single atom of gold? We've already given out the spoiler that an atom of gold would not look golden. But why not? Well, in order to explain that, we have to briefly remind ourselves of how we as humans perceive the colour of an object at all. The light from our sun, and most modern light sources, is approximately white. When we say white, we mean that it contains a broad, approximately equal mix of the wavelengths that our eyes can detect. This ranges from what we think of as red, at a wavelength of about 800 nanometers, down to violet at around half that size, about 400 nanometers. Now, in order for us to see a non-luminous object, for example, this ball, at least some light must reflect off it and enter my eyes. Some wavelengths of the white light hitting it are absorbed, and some are reflected, giving my ball a distinct red colour when my brain processes that information. Now, in the case of a gold bar, it has that yellow colour because of the way billions of gold atoms on the surface of the block interact with light, reflecting some parts of the spectrum and absorbing others. More yellow and orange light bounces off it, and so the object looks, well, golden. One gold atom, or indeed an atom of any substance, just can't do that. In fact, a single gold atom is too small to interact with light waves in the visible portion of the spectrum at all. They just pass it by. So not only does a single atom of gold not look golden, in the terms of the model we've just described, it doesn't really have any colour at all. So, alright then, what about conduction? Gold is a metal. Metals conduct electricity. So what about a single atom of gold? Would that conduct electricity? Well, in order to do that, we need to pass a charge, which is often electrons, from one place to another. The electrons around a single atom would have nowhere to go, And so, no, it can't conduct either. We can bend pure gold quite easily. It's actually quite a soft metal. The correct word for that is malleable. But what is happening when we do bend it? Well, the atoms are held together by strong forces in that solid block of gold. But the atoms can be pushed around a little. Perhaps a bit like these spheres stuck in this lump of putty. I can bend the overall structure like this. But each individual atom, or plastic ball in this case, retains its shape. So, could you bend a single atom of gold? Well, once again, the answer's no. Finally, let's look at melting and boiling points. At room temperature, gold is most definitely in the solid state. But if we warm it up to 1064 degrees centigrade, the particles will start to move past each other and it will melt, transforming into the liquid state. Heat it further to 2836 degrees centigrade and all of those atoms will have enough energy to bounce off each other and leave the bulk, moving into the gas state. In other words, we would have reached the boiling point of gold. So what about a single atom? Can it have a state? Well, no, it can't. States are defined by how particles interact. This single atom has nothing to interact with. So not only can it not have a melting or boiling point, it can't really have a state at all. In fact, there's only one point from the initial description that we can apply to the individual atom. It is a metal. Chemistry defines a metal element as one that will form positive ions by losing electrons. And even that single gold atom is capable of this. So, yes, it is still considered a metal. How might this turn up in an exam question? Well, there haven't really been any specific examples of this exam question at this point, at least not on the UK AQA exams, but we can certainly imagine the sort of question that the examiner would ask. It would probably be something along these lines. If you have a look at it, you can see that we're asked to split the properties of a substance into those associated with the bulk of the substance and facts about the individual atom. In general, we only apply facts relating directly to atomic structure to the individual atoms, and pretty much everything else is what we call a bulk property that is only useful if there are hundreds, millions, billions of atoms all grouped together. The exception is that classification as a metal, or in some cases obviously a non-metal, which would apply to atoms as well as to the bulk. There is a worksheet available on my Patreon page, which you are free to download and use to help you to remember the information from this important topic. You might want to head over there and check it out now. It also has exam questions for this next exam point that I'm about to come onto. What state a substance would be at a given temperature? And this is a question the examiner is quite keen on asking. So pay careful attention, and here we go. The questions always look something like this. So in these relatively common questions, all we have to do is work out whether we are considering a temperature that is below the melting point of the substance, above the boiling point of the substance, or somewhere between those two values. Now, in reality, a lot of students make mistakes here, And it's not because the question is particularly difficult, it's just that it's easy to make a mistake unless you use this method. I've taught this approach to the exam questions for years, and it always works. Simply start off by drawing a straight, horizontal line that will become our number line. Just like in a maths question, the high numbers will be on the right and the low numbers on the left. Now add 2 arrows to your line like this. Mark the right-hand one as the boiling point and the left-hand one as the melting point. Then just add the numbers from the table of data that you were given in the question. In this case, for our gold bar, they would be 1064 and 2836. Then look for the temperature the examiner has given you and just put it onto the number line. Now we've been told that that is 800 degrees centigrade, and so it is to the left of the melting point. And so indeed we have a solid at 800 degrees centigrade. We'll have a look at another exam question. Let's try oxygen at minus 148 degrees C. Will that be a solid, a liquid, or a gas? Well, we'll draw the line, add the arrows, and then add the melting point number for oxygen at minus 218 and the boiling point at minus 183 degrees centigrade. Here we can see that our given temperature, being minus 148 degrees centigrade, goes above the boiling point, and so we know that oxygen will be a gas at minus 148 degrees centigrade. Here's an actual exam question from a few years ago. It's asking us about bromine and gives us the same key facts. So let's start by sketching out bromine's number line. There's the minus 7 for the melting point and 59 degrees C for the boiling point. The first number, 0 degrees C, is between those two marks, and so bromine is a liquid at 0 degrees centigrade. Now for 100 degrees centigrade, well, that's above the boiling point, and so it is a gas at 100 degrees centigrade. And there we have it, an exam mark in the bag, and we can move on. Please practice these skills with the worksheet I've linked in the description. This is a very common exam question, and it's straightforward marks like these that we've always got to make sure we collect when we sit an exam. Good luck with it, and I'll see you here for the next episode when we will look at the reasons why substances have different melting and boiling points.